We want the derivative of this function here, and if you can remember what the derivative of arctan is, that would work best. In this case, the derivative of arctan of just x is 1 over 1 plus x squared. In this case, we have a function inside of that, so derivative of x squared is 2x, and you multiply it by the derivative of the outside, which is 1 over 1 plus x squared, but you evaluate it at the inside. So it's not going to be x squared, but x squared squared. So we got x squared squared, and now you can see that we have 2x 1 plus x to the fourth. That's going to be, b. If you don't remember that, what you can do is look at the derivative of arctangent by itself and just ask, what's this derivative? Well, to do that, we can take tangent of both sides. So we get tangent of y equals x, and we can take a derivative of both sides. So the derivative, so what I'm going to do is I'm going to do ddx of both sides here. And we can use implicit differentiation on the left. So the derivative of the inside is going to be y prime, or dy dx. The derivative of tangent is secant squared of y. Evaluate still at the same thing. And then derivative of x is just going to be 1. So now we get y prime equals 1 over secant squared y, which of course is just cosine squared of y. Now at this point, if you're asking, well, how do we solve this, right? Well, what we can do is we can actually look at, again, this tangent y of x. This is actually a right triangle. Use right triangle trig. Same thing as x over 1. So if this is the angle y, it has to be an angle since it's inside tangent. And then tangent is opposite over adjacent. So opposite is x, adjacent is 1. That makes the hypotenuse x squared plus 1 and the square root of that. So cosine of y is adjacent over hypotenuse. So we have adjacent over hypotenuse, and that is all squared, which of course gives us 1 over x squared plus 1. That's going to be y prime, or the derivative of tangent. And of course we have arctangent, or sorry, arctangent is what we're looking at. That's what y equals here. So y prime is this whole thing. Of course, we have arctangent of x squared, so you have to still do this whole process here. But that's how you can derive the derivative using the right triangle trig.